direct current at 0.5 of 1 mile per hour.
Wow. Okay.
At 1 mile an hour, it makes alternating current, and then it has a diagonal power curve all the way up to about 250 miles an hour.
So it's spinning at 250 miles an hour.
Yep.
It can take it.
But when you get that high, it doesn't, mechanically doesn't start to break down. I mean, it can
Well, you
handle,
know what's nice about
torque,
a wheel?
There's a torque.
I'm a car designer, okay?
Yeah.
You know what's great about wheels? The faster you spin them, the more stable they get.
And that's the dynamic that happens
Yeah,
here.
just like jet engines. It works that way. In fact, this works better than a jet because, in fact, this part reminds me very much of something we created for a new airplane. It's a part that's on the Lockheed F-35 Joint Strike Fighter.
Okay. Okay.
Take one of these and put it horizontal, like this.
Right. That's
and then
how you
run it like so.
Mm-hmm. Mm-hmm.
We run it from the exterior rather than the interior.
Okay.
Which means that we can create a humongous amount of power
and thrust with that.
With very little torque.
Is that how you lift it then?
Takes off.
The power's
wow.
Go see the latest. Go see the latest. Live Free or Die Hard.
Yeah, we just did. Yeah.
Yeah, that's the airplane in there. It turns into the wind like so.
And does it need a motor to run off of power to do that?
No, you just let it go.
And so it'll
You
yaw
let it
on
go
its own,
in even
grabs
this
the
little
wind on
amount
its
of
own.
wind. You know, there's not a lot of
It picks
here.
up.
Look,
And
it's
it picks
going.
up real fast.
Like you can barely feel the wind.
Mm-hmm.
Yeah.
Long
You see,
lesson.
the thing about these old propellers here
Right.
is that my favorite guy in the world, his name was Kelly Johnson, okay? Fabulous aircraft engineer at Lockheed. He designed this kind of propeller back in 1944. Some of the best propellers ever designed were designed for an airplane called a P-38 Lightning.
Right. Right.
That was the first aircraft that went over the speed of sound in a dive and went out of control, but we don't want to. But basically, that was the best propeller ever made.
Okay.
So what we did was, you know, General Electric and all the others are using blades that are elongated versions of that P-38 blade.
Yeah.
Taking wind reading?
No, temperatures.
Yeah, wind readings would be good to have right now, because it's probably about 5 miles an hour. So basically, if Kelly Johnson was alive today, he would have said, "Brad, these idiots at General Electric, why did they copy my 1944 design? Why didn't they copy my 1960 design for the SR-71 spy plane?
Yeah, exactly.
Idiots." Ah.
Yeah.
So, you know,
5-6 miles an hour.
no, that's 1.1, 1.4,
Oh, okay.
2.2, you know.
Now, you just
We're not going very fast.
power now, or no?
Yeah.
We
Well,
took the chain.
I took the chain off just now because, well, frankly, it went offline a little bit. But, yeah, when David showed up, we were making about enough for this house and the house next door.
That's a small DC motor down there?
Yeah,
DC
it's
generator type thing?
okay. In this case, we're going to do something which is very different when it comes to this, too.
Okay.
I've always been completely unimpressed with General Electric's windmills,
Yeah.
or
Yeah.
Vestas, or
Yeah.
what they use is they use Vestas are nice, they're beautiful, but you know,
No, I'm not.
They
That's not an
use
issue.
these,
I hurt my feelings. I'm just saying. I remember that one.
yeah, they use permanent magnet motors
Yeah.
or
Okay.
generators.
Yeah.
Okay? So the problem with a permanent magnet motor is that it has a single resistance.
Right.
Okay?
Right.
Well, I'm a car designer.
Okay.
What idiots would put a single resistance generator in a machine that costs $1.8 million a megawatt? That's nuts. Because car designers, we use alternators. Okay?
Right. Okay.
So, but if you do have very little wind, maybe that's 10 hours a day. It builds up.
Yeah.
It's the little wind that you catch, you know, that is constant, consistent, you know?
Right. Right.
And then when you can get up to, what, 2 miles an hour now, you can really get some speed.
Yeah.
So, in this case, today, a General Electric windmill
Yeah.
has a generator in it,
Mhm.
a lot like this little one we have here.
Okay.
It has 6 magnets
Okay.
in it.
Yeah.
These are permanent magnets.
Right.
And it's just like, you know, high school science class. I mean, it's ridiculous how
Right.
they've done this.
Right.
But they did it because they got stuck back in the 40s. Back in the 40s, they started making things big. What did they use? They used diesel power to begin with. So all of these triple-bladed monstrosities have kind of come from diesel.
Yeah.
Now, when you start with a diesel engine, you're talking about 3,000 RPM to get a peak power.
Yeah.
So when you take 3,000 RPM and multiply it times 6 pole changes,
Right. You got it.
you got alternating current. You
Right.
got 60 hertz, which is 60 pole changes
Oh,
per.
okay.
per
That's where it
second.
came from. Okay.
Okay?
Uh-huh.
So you got 60 hertz. Now that's great, but we don't have 3,000 ever on this
Right,
thing.
right.
Even if you're at 250 miles an hour,
Right,
we
it
don't
doesn't get
intend
that
to even
fast.
get close to
Wise, yeah.
that kind of RPM. So what do? We innovate, and another one of the patents is we've got a way of making a magnificent new kind of alternator generator,
Yeah.
which is such that instead of having 6 pole changes per RPM, it has 6,000.
Therefore, at
Therefore,
3 RPMs,
Is it electronic?
It's like
is it
computed.
feed it? You feed it
With
DC?
200,000.
yeah. Yeah.
This is a glass in there.
So what it is
If
it's
if
set
one
up
works like this,
so that
put more of them in
if
there.
this thing is running
Uh-huh.
at 1 mile an hour,
Right. Right.
we're at 60 hertz, and we can go over to alternating current right there.
Yeah. Yeah.
Once we're there, then when you go from 1 mile an hour to 250 miles an hour,
Yeah.
all you have to do is add juice onto the electromagnets that are in the center
Right.
to form not only a brake, but also pull off massive amounts of power.
Power.
And the amperage just goes whoosh up.
Yeah. Yeah. It
Okay?
goes way up.
So we intend to make custom generators here
Yeah.
that for the first time can go right to the grid. They'll
Okay.
be at 137,000 volts
Now you control.
from the start.
Are you controlling that with what it's like soft start type of technology? Is it electronic technology, solid state stuff that's doing that with electrical?
You know, we found a way to do it mechanically.
Mechanically?
Yeah, so that it'll never break down. We don't have a single computer in this thing.
Well,
In
that's
fact,
good.
you know what? I design cars,
Yeah.
and one of the first things that breaks
Is
is
the
the
computer.
computers and,
Yeah,
and
yeah.
the silicon and the,
So
and the
it's
things break down
so
that way.
it's durable then, rugged is what you're saying. It's, the fact that it's mechanical has that advantage.
We're looking at something so simple here that
Yeah.
the only thing that'll break, the only thing that is in contact
Right.
are the bearings.
All right.
And the bearings are made by a lovely company called SKF.
Yeah. I know.
SKF makes some of the greatest bearings on the planet. I love these guys, okay?
Okay.
And of course they like this.
Yeah.
They look at this and they say, well, you don't need one of our big bearings for this, number one. You know, I just went to this marvelous presentation at the Convention Center in Los Angeles. They had the American Wind Power Association there and 300 companies in wind. And my partner Steve Huntsman and I, we walked around that convention center and looked at like 200 companies that make windmills.
Yeah.
And they all make triple-bladed windmills.
Yeah. Yeah.
So what's the technology they're trying to refine? Is it their ball bearings they're using, or they're trying to make more special? What are the things they're trying to make more special with that same technology?
I walked
They're
up
just
to
stuck.
a booth made by a company from Finland that makes the transmissions for these humongous windmills.
Yeah.
And the transmission itself costs as much as a Lamborghini.